Okay, here's 3.2. A building contractor determines the total cost of a job is $45,000. Labor costs are $15,000. What decimal fractions of the total cost is labor? Your answer is going to be it's going to start as a fraction. Okay? Labor over the total. Well, the labor cost is $15,000, and the total cost is $45,000. Now that's your fraction, but you're going to divide it. 0.3 repeating. Okay, you can get a repeater. That's okay. The displacement of an auto engine is 120 cubic inches. The engine is rebored an additional 6 cubic inches. What decimal fraction of the displacement of the rebored engine is a decimal fraction of the displacement of the rebored? Okay, I wrote this like an idiot. Okay, what decimal fraction of the displacement? Start crossing out there. And start it is, because now I read it, it'll make more sense. The displacement of an auto engine is 120 cubic inches. The engine is rebored an additional 6 cubic inches. What decimal fraction of the displacement of the rebored engine is the displacement of the engine before rebore? Okay. So, it's really a pretty easy problem. You got your total and the amount that was rebored. Okay. So the total was 120, and they rebored 6 cubic inches, so I take 6 divided by 120. 0.05. Again, they want the decimal, they don't want percents or anything like that. Okay, number 3. A mason lays a sidewalk to the dimensions shown. So A is a distance of 40, B is a distance of 20, C is a distance of 10, D is a distance of 25, E is a distance of 32. And those are in feet. Okay, 1 apostrophe means feet, 2 apostrophes mean inches. What decimal fraction of the total length of the sidewalk is distance E? So it's essentially E over the total. So E is 32. Now the total, I think we're going to have to add them up. Okay, so 20 plus 40 plus 10 plus 25 plus 32. 60, 70, 95, 120, 127. Okay, so I divide 32 by 127 and 0.25 round to the nearest tenth. Okay, what decimal fraction of the total length of the sidewalk is distance B plus distance D? Okay, so B plus D over the total. Well, I know the total is 127 from the previous problem. B plus D, so it'd be 20 plus 25. That's a D there. 20 plus 25 is 45. Then I take 45 divided by 127, 0.35. Watch yourself on number 4. The interior walls of a house contains a total area of 4,200 square feet. A painter and decorator paint 2,250 square feet. What decimal fraction of the total wall area is the area that remains to be painted? So you got to watch yourself on this one. You got your total, but we don't want the painted part on top. We want remains to be painted. So the total is easy. It's 2,250. Okay, or no, 4,200. That's your total. It says so. Total 4,200. Now, this is not the amount that remains to be painted. That's how much you've already painted. To find what you have left to paint, you take your total 4,200 and minus your 2,250. Read the problem. I'm not a reading teacher, okay? You have to kind of 19,950. Okay, if you want me to explain it to you, that's fine. Okay, but so the remaining part, remember, not the painted part, the remaining part I divide 0.46. So I don't want to use just 2250 because that's what they have painted. The remaining to be painted, I need to subtract that from my total. Okay, number 5, a hospital allows 900 calories for a patient's breakfast, 1,050 calories for lunch. The total daily intake is 2,800 calories. What decimal fraction of the total daily calorie intake is allowed for breakfast? So it's the total, and then they want breakfast. Easy problem. Total's 2,800. Breakfast is 900. Okay, so it's 900 divided by 2,800. Okay, 0.32. You don't really label these either. Okay. What decimal fraction of the daily caloric intake is allowed for lunch? So total. Now they want lunch. So the total is still 2,800. That doesn't change. Okay. Lunch 1,050. So 1,050 divided by 2,800, 0.38. Okay, then the last one, you got to do a little bit of thinking, but not much. What decimal fraction of the daily caloric intake is allowed for dinner? Total dinner. Well, we have our total at 2,800. Now find your dinner. Well, they don't tell us a dinner. Well, I'm going to need to do some subtracting then from my total. So it's 2,800 minus the breakfast minus the lunch. And the remaining amount is how many calories I intook at dinner. Don't think I said that properly, but okay, 850. So now I take 850 divided by 2,800. So just because something's not given to you, you can just subtract if you know from your total. The other part, 0.30. Next one. In pricing merchandise, retail firms sometimes use the following formula. The retail price is the cost of goods plus the overhead expenses plus their desired profit. Retail price is the price the customers charge. Cost of goods is the price the retailer pays the manufacturer or supplier. Part A, what decimal fraction of the retail price is the desired profit for item A? Part B, what decimal fraction of the retail price is the overhead expense for item B? We need to figure out some missing information in this table, okay? So, when we don't know the retail price, it says we're just going to be adding, okay? So 500 plus 75 plus 48. So $623 is a retail price. And then I essentially, for item B, I repeat the same process. 150 plus 25 plus 17, okay, 192. Now here we know the retail price, we got to find the profit. Where's what I'm going to do? So in this formula, I'm going to go 1,500 equals cost of goods 500, overhead expenses 330, plus a profit, which we don't know, okay? Well, I can easily find it if I just take 1,500, the total, and then subtract these that I know. You can subtract them individually, or you can add them and then subtract the sum from that. So $670 is the desired profit. Now we're ready to roll. What decimal fraction of the retail price is the desired profit for item A? Okay. So it says of the retail price. So retail is like your total, and then the profit goes here. So for item A, the profit's 48, the retail price 623. 0.08. Okay, what decimal fraction of the retail price? So when it's after, if it says after of, that's what goes on the bottom, and then overhead expenses. So overhead, and they're talking now about item B. So $25, and then 192. So 25 divided by 192 is 0.13. Okay, number 7, easy problem. Tom's job needs 22,335.6 meters of cable for a wiring job. How much cable is this to the nearest meter? Nearest meter means you're rounding to the nearest, the number right before the decimal. Okay. That's going to go to a 6, because after it's a 6, it's higher than 5. So 5 goes to a 6. Everything before it remains the same. Everything after it's dropped. Okay. 22,336. Okay, number 8. Stephanie used the following amounts of cable during the first 3 months of the year. January, 10,429.8 meters. February, 15,684.45 meters. December, 5,429.785 meters. Part A, round each amount to the nearest 10 meters. Okay, nearest 10 meters, so the 10, not tenths, it says 10, okay? Nearest meter, nearest tenth. So the tens are before the decimal. If it doesn't have TH after, it's before the decimal. Okay, so that's the ones, that's the tens. And that 2 is going to go to a 3. Everything before it stays the same, okay? And also, you can't drop, you have to put the 9 as a 0, okay? You can't drop zeros before the decimal, okay? Everything after does become a 0 after that, when it becomes a 3, but I need to write the 0 that's before the decimal. The one after it I don't worry about. Okay, next one. So that's first answer. Then ones, tens, so that's going to stay in 8, 6, 1, 5. Now there's a 4, that 4 is before the decimal, so I need to put a 0 for that. Okay, so 15,680. After the decimal we can drop. December, okay, 10. So that's going to become a 3, so 5, 4, 3, 0. Drop what's after the decimal. And you label it, just put M for your label. That's how you label meters. MI is miles, M's meters. Now you're doing the nearest meter, so that's one place. Okay, that's the place right before the decimal. So that 9 is going to go, well, there's nowhere for a 9 to go, so then the digit before it becomes a 3, so it'll be 30. Okay, so 10,430 after the decimal, don't need it. They can be the same. Okay, ones here, that'd be, now I'm rounding the 4, that would stay a 4, so 15,684. And then there's stuff after crap after the decimal we drop. Okay, nearest meter, the 9. Again, there's nowhere for a 9 to go really, so then the one before it becomes a 3, so it's 5,430. And then the zeros after the decimal can then be dropped. Okay, nearest tenth of a meter. Now you're rounding that place there. Well, there's nowhere for that 8 to go, so I essentially just write down the same number, and the label on this is meters. Okay, tenths. Remember it says TH, so tenths is the first place after the decimal. Okay, so we're rounding the second 4. That's going to go to a 5, so we're going to have 0.5, and everything before the decimal stays the same. Okay, and then right here, tenths, that's the first digit after the decimal. Now there's an 8 after it, so that 7 becomes an 8. Everything before our decimal stays the same. Now the zeros at the end, those are after the decimal, so I don't need to include those. Okay. Simple rounding. Okay, now the next part, we got some exponents here. They're actually pretty easy to figure out. 0.8 to the second means 0.8 times 0.8. Okay, it's just multiplication of the same factor. Okay, it's 0.64. 1 to the seventh means 1 times 1 times 1 times 1 times 1, but it's just 1 because I'm multiplying nothing but ones. The power really doesn't matter. 0.04 times 0.04. That's called the base, that's called the exponent. 0.0016. 315 to the second, 315 times 315. 99,225. Okay, 0.24 to the third power. So it's 0.24 times 0.24 times 0.24. 0.013824. 0.13 to the third power. 0.13 times 0.13 times 0.13. 0.002197. You don't have to write it in word form, but that would be 2,197 1/10, 100,000, 10,000 millionths. Okay, 3 to the fifth, that's simply taking 3 times 3 times 3 times 3 times 3, 243. And then 0.009 to the third gives us that. 0.000000729. So in word form, that'd be 729 tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths, 100 millionths, billionths. 729 billionths. You don't have to write it in word form, though, thankfully. Okay, fraction exponent, 1/2 to the third. That means 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. You essentially raise the numerator and denominator both to the third power. Do this one, be 3/8 times 3/8. That's 9/64. Now you need to simplify your parentheses first. I add those, it's 3 whole. And then 3 to the fourth is 81. I'm going to start picking it up here. 14.8 minus 11.8 is 3. 3 raised to the fifth power is 243. 2 plus 0.5 is 2.5. When I take raise 2.5 to the second power, that's 6.25. 13 raised to the second, that's going to be 169, and then 20 raised to the second is 400. Don't worry about reducing. You won't, if you can't reduce 13 over 20, when you raise both to a power, you're not going to be able to reduce that either. Okay. 1,000 times 1,000th. Well, that's 1. Okay. 1 to the 8th power is 1. 175 times 0.04 is 7. But when I raise my 7 to the second, that's 49. Okay, next page. Now, that was powers. Now we're going to do the opposite of powers, which is roots. Okay. The square root of 25 means it's a square root. It's asking you question mark to the second power equals 25. That means what times itself equals 25? Well, I think it's 5. Okay. Square root of 49, what number when taken to the second power is 49? Okay, that means what times itself is 49? I believe it's 7. Now, cubed root, that means what to the third power equals 27. So it means what times what times what equals 27. It's not 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, so it's 3. Okay. Now, yes, your calculator can do it, but you can't do. You got to pay attention here. Square root of 25. I go second and then hit the key next to the 7. 25. Cubed roots, you do not go 3 and hit the number next to the second. That's wrong. The 7. That's wrong because that's taking 3 times the square root. Okay. You punch in 3. You hit second, and you hit the key above where you were at before. It should look like that. So 3. Okay, what to the second equals 144? Well, I could square root 144. That's 12. 12 to the second is 144. What times what times what is 64? It's not 1, it's not 2. 3. We know it's not 3. About 4. Yep, and also I could go 3 second, but then you hit the caret, not the x squared when doing a cubed root. 4. Okay. So what to the... Okay, fifth root of 32. So it means what to the fifth power is 32? Well, it's not 1. I think it's 2. Okay. Now the fifth root's the same as a cube root. I go 5 second caret, but in the upside down V, 32. Okay. Now, when you have a fraction power, and if you took Algebra 2 last year, you rewrite that as a radical with a 5 here. The 1 can be dropped. So essentially you're finding the fifth root of 32, which I know from up here equals 2. The 1/3 power, so it would be a radical, it would be a cubed root. The 1 can be dropped. Now if there's like a 2, you'd need to take the answer to the second power after you were done, but it's just a 1. So it's going to be 1 million. So I'm going to go 3 second caret 1 million. 100, okay? So those fraction exponents are really radicals, okay? Okay, then we go here, 3.1 plus 12.9, 16. You got to simplify. It's like a parentheses. You have to simplify. Square root of 16 is 4. Remember, if it doesn't have a number up there, it means what to the second is 16. It's 4. Okay, first I simplified. Do not try to do the square root along with that. You need to simplify the inside first. Okay, it's 49. Then I do my square root. What to the second power is 49? What times itself is 49? It's 7. Okay, I'm going to add these two. That's going to be 100. And then what to the second equals 100? I believe it's 10. Okay, we have a cubed root. So 127.3 minus 63.3 is 64. And then what to the third power is 64? Well, 3 second caret 64 is 4. Okay, you need to do the operation inside before you do the root. 54.4 divided by 3.4, I got 16. Now the question is what to the fourth power would be 16? Okay, that's what the fourth root of 16 means. It means what times what times what times what again would be 16. It's not 1, I think it's 2. Okay. Add those, it's 125. So what times what times what is 125? What or what, however you want to think about it. What to the third power is 125, or what times what's 125? It's 5. Okay.